Next, we'll discuss the second scheduling, which is shortest job first. In the previous video, we have discussed about the first come first serve scheduling and advantages and disadvantages. Now, second scheduling is shortest job first. And we saw the example. So, in the first example on the FCFS, the order of execution was P1, P2, P3. Later, we updated to P2, P3, and then P1, and then we comparatively got the better result when compared with the FCFS. So in this case, the same order P2, P3, P1, and all the jobs are arriving at same time. And we are calculating the waiting time of P2 is 0, P3 is 3, and P1 is 6. And then completion time of each process is P1 is 30, P2 is 3, and then P3 is 6. So when you find the average waiting time, it comes to 3. And when it compared with the FCFS, it is far larger, which is 17. And for average turnaround time, it is 3 plus 6 plus 30, average to 3, which is 13. And which again, it is comparatively far better than FCFS. So in this case, which are all the short execution time process will be executed fast, and then they will leave the system. They need not wait for the lengthy burst time process. And this is one more example. So here all the processes are arriving at different arrival time, and the case is non-preemptive. And here the process, there are 4 processes P1, P2, P3, P4, and their arrival time is 0, 2, 4, and then 5. And correspondingly, their execution, the burst time is 7, 4, 1, and 4. So when we draw the Gantt chart, so at time 0, the process P1 arrives, and since it is of non-preemptive category, all the process will get the P1 will get completes its execution completely at time 7, and then meanwhile all the remaining process P2, P3, P4, they arrive at 2, 4, and then 5 time interval. So now when the P1 completes its execution, all the 3 process P2, P3, P4 will be in the queue. So in that, when we check the shortest execution time, which is P3, when compared to P2 and P4 is lesser. So P3 gets its execution and then it completes at 8. And again P2 and P4 has the same execution time, which is 4. But P2 arrives at 2 but P4 arrives at 5. So P2 gets the chance first. So it completes its execution at 12, and then P4 next it follows the execution and completes at 16. And when we find the average waiting time, so it comes around to 4. So here how we need to calculate the arrival time is, so arrival time of process P1 minus starting time, so 0 minus 0. And again what is the arrival time of P2? Arrival time of that is execution time when it gets started at time 8. So when it gets arrived at time 2, so 8 minus 2. And same way P3, it has arrived at the time 4, but it's starting its execution at 7. So 7 minus 4 is the waiting time. And same way P4 arrives at 5, but it is starting its execution at 12. So 12 minus 5, it is 7. So which average to 4 gives the value 4. And completion time. So P1 is arriving at 7, 0, and it's completing at 7. So 7 minus 0 is the completion time of P1. And for P2, it is arriving at 2 and it's completing at 12. So 12 minus 2. And same way P3, it is completing at 8, but it is arriving at 4. So 8 minus 4. And finally the P4, it is completing at 16, but it's arriving at 5. So it comes around to 11. So when we take an average, the value is 8. The next category is the same version with the preemptive time. Preemptive with varied arrival times. So there are 4 processes P1, P2, P3, P4 with different arrival time and burst time. So here at time 0, the P1 starts its execution and it executes for 2 seconds, and meanwhile the P2 arrives. So when we check the execution time of the P2 and P2 is 4, and meanwhile P1 will be 5. Already it has completed 2. So P2 is lesser when compared to P1. So P2 gets its execution time. At time 4, P3 arrives. And when we compare the execution time of P3 and then P2, P2 will be 2 and then P3 will be 1. So 1 is lesser than 2. So P3 gets its execution and completes at 5 and then leave the system. And next when we compare so in the meanwhile all the process would have arrived by 5. So when we compare the execution time, P1 is 5, P2 is 2 and then P4 is 4. So P2 is lesser. So P2 completes its execution. Then P4, its execution time is 4 but for P1 it is 5. So P4 gets executed first and then followed by P1 which completes at 16. So when we find the average waiting time of this, so for P1 it is it is executing in two phases. So P1 at 0 and then P1 at 11. So 0 minus 0 and then 11 minus 2 will be the waiting time of the P1. And for P2 it is executing 2 times. So 2 minus 2, the first waiting is 0 and for the second 5 minus 4, 1. That is the waiting time of P2. And for P3 it is 4 minus 4, so it doesn't wait. And for P5 it is for P4 it is 7, it is arriving at 5, so 7 minus 5 it's 4. So when you take an average it is 4. To average to 4, the answer is 3. And when we find the average turnaround time, it comes around to 7. So the advantages of shorter job scheduling is, so it works based on the CPU burst, it gives optimal waiting time, and the main drawback is the longest job gets stuck between the short ones. Thank you.